Hi friends, in the previous two videos we discussed about the introduction of the brakes and the working of the conventional brake system. This video I'm going to talk about I am going to talk in detail about the critical components involved in the brake system. Friends, we discussed about how the conventional brake system, that is power assisted hydraulic brake system, works in the passenger cars and the light and medium commercial vehicles what you use in our regular life. Now in this video let us look into the components, how they built and how they functions, about the components which are fitted in this conventional brake system. So I'll just brief quickly which are the components involved in the brake system. That is, first the brake pedal, the next is the brake booster, then the brake fluid reservoir, then the master cylinder, then the piping here and here, then the rear wheels, that is the drum brakes with internal expanding shoe and its components, and the front side is the disc brakes with caliper assembly. Let us go in detail about one component. To start with the brake pedal is a metallic arm or linkage pivoted at one end, connected to a push rod in the middle and having a lever to press through the foot operation. So, and this lever is somewhere connected to a return spring. So as long as there is no load on this brake pedal, this lever is held with the help of the return spring, and when the brake pedal is depressed or pressed with a foot, this push rod is actuated and move forward, which actuates the brake booster. This is the job of the brake pedal. Sooner the load is released on the brake pedal with the help of the return spring, the pedal comes back to its original position. Then coming to the brake booster. Brake booster is a metallic round box having two chambers. This is one side the chamber, that is the chamber at master cylinder side is called the vacuum chamber, this green place. This vacuum chamber is connected to the engine through a vacuum tube. As long as engine is in operation, engine is running, vacuum is maintained in this chamber. The other side is called the pressure chamber. This pressure chamber, sometimes as and when necessary, it allows the air from the atmosphere. How it works, I'll explain you. So these two chambers are separated with a rubber diaphragm. This is the rubber diaphragm separating these two chambers, vacuum chamber and as well as the pressure chamber. This rubber diaphragm is attached to a metallic piston, this one. And if you observe this vacuum chamber also is having a spring, lightweight spring, which is placed in between the piston and the inner wall of the booster. So the purpose of the spring is, when the brake booster is not actuating, this keeps this piston away from this wall, maintaining this space, vacuum space. Right. Pressure side, this one. This is the push rod from the brake pedal, and there is a puppet valve here, and puppet valve seat is here, and there is a spring is here. Okay, keeping the puppet valve always towards the face of the seat, and there is an air filter is here. So let us assume what happens when the brake is applied. When the brake is not applied, a vacuum is created here in this chamber, here nothing. Let us look what happens when the brake pedal is depressed. When the brake pedal is depressed, this push rod will move forward. When this rod is moved forward, it pushes the puppet valve to forward. When it pushes the puppet valve forward, the gap is created between the puppet valve seat and the puppet valve. When the gap is created here, the air from the atmosphere is entered in this chamber. The air is entered through this filter. A filter is provided. The job of the filter is to filter all the impurities, dust particles, any foreign particles here itself, that is preventing the entry of any dust particles inside the chamber. The air is entered here through this valve gap, and This chamber is pressurized with the atmospheric pressure. The air pressure in the atmosphere will be normally 1 bar, that is 1 kg per cm square approximately. That is approximately 14.5 pounds per square inch. Here it is 0 pressure. Here it is 14.5 psi pressure. Because of this pressure difference, this piston along with the diaphragm, this piston is moved forward against the tension of this spring. When this piston is moved forward, along with this piston, this spool also moves forward. This spool is connected to the master cylinder. This is the tandem master cylinder. When the spool is moved forward, the brake ports are opened in the master cylinder, pumping the brake fluid to the wheel cylinders or the brake calipers as the case may be. The moment pedal load is released on the pedal, this puppet valve is closed and air entry is stopped here and the pressure becomes 0, and with the help of this return spring, the piston travels backside to its original position, releasing the brakes. This is how the brake booster functions. You can see how the brake booster looks like. This is how brake booster looks like. This is master cylinder side, because the master cylinder is connected to these bolts and push rod will go inside. This is the brake pedal side. You can see how it functions. This yellow color is the entry of the atmospheric air. This is the vacuum chamber. These bellows are provided. In addition to the filter, these bellows are provided to protect these parts from the dust and other foreign particles. The next part is the master cylinder. Friends, this is the master cylinder. This is called tandem master cylinder. In majority of the present generation vehicles, tandem master cylinder is being used. In olden days, the master cylinder is having only one piston, one spool inside was used. In present days, tandem cylinder is nothing but the master cylinder having two pistons. This is one and this is two is being used. Okay, and it is having two delivery ports, and two delivery ports are connected to two wheels. Each port is connected to the wheels. Normally, one port is connected to the front wheels and one port is connected to the rear wheels. In some cases, these ports are connected to the diagonal wheel also. Suppose front LH and rear RH, or front RH and rear LH. So the purpose is, in case one piston fails or leaks inside, at least the second piston will work momentarily and the machine can be stopped safely. This is the main purpose by having tandem master cylinder. This is the tandem master cylinder, and this is the master cylinder body, and inside these are the pistons, and these are the return springs, and these are the valves, proportionating valves, or the ports you can say, and inside you can see the inlet port. This is fluid control valve, means the inlet port, and there is an inlet port. Okay, and the fluid reservoir is fixed to the master cylinder, always maintaining the brake fluid at minimum or maximum levels, whatever may be. This is about the master cylinder construction. Then what happens, how it functions, let us see. So when the brake is applied, as we have seen in the earlier case, the booster is actuated and the booster push rod pushes this spool to forward. This is the primary piston. When this spool is pushed forward, first of all, the inlet port is closed here. So imagine the piston may be somewhere here. First of all, the inlet port, whatever is here, it is closed here. So whatever is oil already available here is being pumped. Where it is pumped? It is pumped through this port to two wheels, whether it is front wheels or rear wheels. Simultaneously, this fluid pressure also acts on this secondary piston, and secondary piston is moved forward, closing this port and creating pressure on this outlet port. This is how it happens. So when the piston or the spool is pushed by the brake booster, the primary spool is moved forward, closing the inlet port pumping the oil available in the master cylinder chamber and pumping to the lines and as well as the connected wheels, whether it is a wheel cylinder or the caliper pistons. Same way, simultaneously, it happened in the secondary spool or secondary piston also. Like this, the oil is pumped to the brake parts. Master cylinder's job is nothing but pumping the fluid as and when brake is applied. The moment brake is released, the piston and the push rod goes back to the booster, and with the help of the return springs, these spools or pistons inside the master cylinder comes back to its original position, opening this port and this port, allowing the oil to enter into the fluid reservoir or brake oil tank. There are some vent holes are provided in the filler cap to release the air during the brake operation. And in addition to this, the present generation master cylinders are having some additional safety devices like the balancing valve and all, so which we can see specific to a particular model of the vehicle. The master cylinder looks like this. You can see this is the primary piston and the spring. You can see the secondary piston and the spool. These are the discharge ports, 1, 2. These are the inlet ports, okay, connected to the reservoir. This is the push rod. This is how it looks when it is assembled, master cylinder as well as the reservoir. The brake fluid from this one of the port goes to this piston of the caliper disc, pushing this piston, then this brake lining holding the rotating disc. Same happens here, going here to the wheel cylinders, causing expansion of this shoe, holding this rotating drum. Now the is the wheel cylinder and the wheels. This is internally expanding drum brakes. These are the parts we can see in this internal shoe drum brakes. First of all, this is the brake drum, and this is the wheel cylinder connected to half round brake shoe. Let us see how the wheel cylinder works. The wheel cylinder. Oil, when the brake is applied, oil pressure from the master cylinder comes to these tubes and enters in this wheel cylinder. When the oil pressure is increased here, because the oil cannot be compressed like air, so oil pressure is increased here, oil will push these pistons outwards. There are two pistons. This is one piston and this is one piston. Both the pistons are having rubber seals over them to prevent the leakage of oil, and both the pistons are kept away with the help of a light tension spring. This master cylinder is connected to this hub bracket and having a hole here. This is the back side of the cylinder. It's a fluid passage hole, that is where this pipe is connected, and the bottom one is the air bleeding hole. These two holes are to fasten this cylinder to this bracket. So these are the rubber caps to prevent the dust entry inside the cylinder, and these are the push rod. This thing under this is the push rod. Oil is coming from the master cylinder with pressure, creating a pressure, causing the outward movement of these pistons. When these pistons are moved outwards, you can see each piston is connected to the brake shoe here. Each piston is connected to the brake shoe. The moment pistons are moved outwards, even brake lining, brake shoe also is moved outward. When the brake lining or the brake shoe is moved outwards, it holds the rotating drum so that the rotating drum is stopped and brake is applied. This is the cross section of the cylinder. This is the spring, this is the piston, these are the rubber caps, these are the forks, you can say, which are this side connected to the shoe. Okay. This is inlet port. This is how it looks and how it functions. Pump it here, the pedal. Of course, the booster is absent in this in this illustration. This is the master cylinder and this is the fluid reservoir. Fluid is coming with pressure. The pressure causing expansion of this piston outwards, or movement of this piston outwards, moving this brake shoe and holding the rotating drum. Now coming to this wheel cylinder, this is made with a cast iron having inside two pistons, rubber seals to prevent the leakage of the fluid, and also having two push rods or forks outside, and having rubber boot also outside to prevent the dust entry inside, and there is a spring inside holding both the pistons apart from each other. Then the shoe also, or the steel or the cast iron made shoe, over and above this the friction material is bonded on the brake shoe. Some friction material is bonded with the glue, and some friction material, some types it is riveted actually. Drum, it is called the wheel drum or the brake drum. It is made with the cast iron. Okay, these two, the friction material and as well as the drum, are the wear and tear items. The wear depends upon the usage and application of the brake. And the brake material is made with glass fibers and so many other materials. Earlier models, these materials they used to make with the asbestos, and because of the environmental safety, the asbestos is now discarded and they are making with lot of sophisticated materials like glass fibers and other fibers. This is about the drum brakes, the wheel cylinder function. Then let us move to the discs. This is the disc brake. This is the rotating disc made with the cast iron again. This is called the rotor also. These special designed fins are provided for speed, faster heat dissipation. Whenever the brake is applied, these components or temperature is going to be increased because the friction is generated. So application of brake is nothing but converting the kinetic energy into thermal energy. So the heat is generated. Whatever the heat is generated, it has to be dissipated as fast as possible. Otherwise, this disc and pads also are going to damage and brakes becomes weak. This is the rotor connected to the wheel, and this is the caliper cut section. Inside the caliper you can see this is the piston, and this piston is also having a piston seal, and there is a dust boot to prevent the dust entry inside, and you can see this gray color or the brake pads both sides of the drum. This is bleeder screw, and there is a supply port flip there inside. Dust boot, piston seal, piston. The oil is supplied to this piston from this. The piston is pushed towards the disc with the help of the oil pressure. When the brake is applied, the oil pressure acts behind the piston, and seal is provided here to prevent the leakage of the brake oil. The piston is pushed forward. When the piston is pushed forward, this plate pushes this brake pad towards the disc. Simultaneously, the pressure also acts on this caliper housing. The caliper housing is pulled backside. When the caliper housing is pulled backside, the pressure acts on this plate, pushing this friction pad towards the disc. So pressure acting at one end of the piston, at one piston. In this case it is shown only one piston. In some other model there will be two pistons opposite to each. Okay. Here the oil pressure is acted, creating the pressure, pushing this piston this direction, also pushing this housing this side, means pulling from here end this housing. So from here this pad is pushed, and from this housing this pad is pushed. Both the pads holds this rotating disc from rotation. That is, brake is applied. Brakes released, piston, this is oil line, okay, this is a piston, this is the pads, and the brake is applied, oil pressure is coming here, this is moving here, and this complete housing is moving this direction, because this oil pressure whatever is available creates the pressure this side and this side as well. So holding the rotating brake drum or rotor, sorry. This illustration shown is here with two pistons. Don't get confused. It's only for the just for understanding I am showing it here. Oil is coming here, simultaneously oil is going and acting behind this also. So bringing them close together, holding the brakes. The moment the pressure is released, the brake is released, oil pressure is released, oil pressure comes down and the pistons travel back to their position. Okay, making the rotor free from holding, so the rotor starts rotating. The advantage of this disc brake is this is having faster heat dissipation, so the longer life, and the brake grip will be good here compared to the drum brakes. And another advantage, it is having a self-adjusting nature. It's a self-adjusting to certain extent, not completely, to certain life of the brake pads. Yes friends, you can see this diagram resembling the same figure. Brake fluid pushing the piston, pushing this pad, again pushing this housing this direction. So causing to push this brake pad here, holding the rotating drum. This is about the various components involved in the conventional brake system. Go through these 4 pages notes. In case you have any queries, you can always contact me through the email. Next video we'll discuss about the ABS, anti-lock braking system